Welcome back to the promo tutorial series. So far, we've learned about the general concepts behind programming. Today, we'll finally take things into the context of MapleStory Worlds and learn about what makes programming in Worlds unique. Let's begin. Now, up until now, we've been coding with no regard to multiplayer synchronization, but MapleStory Worlds runs in two different environments, the server and the client. During development, you need to be constantly aware of whether your code is running on the server or if it's running on the client. When we were running our general Lua script code, we saw that the code was running on both the client as well as the server. However, now we need to be a bit more conscious and deliberate about how we define our variables and how we define our functions. So before we get too deep into MapleStory Worlds coding, let's first overview exactly what I mean by client and exactly what I mean by server. Now let's imagine for a moment that we are both customers at a restaurant. We're hungry and we want to order some food, but who do we tell to deliver our food? And how does the kitchen know what to make and who to deliver the food to? Well, in this scenario, we as the customers would be the client, and we would be in charge of making the requests and the orders. The waiter then would act as a server who is in charge of processing the requests and delivering instructions to notify the kitchen to begin cooking our food. The waiter would need to keep track of who made the order and when the kitchen is finished processing the order, ensuring that the final product is delivered to the right customer. Now, I want to bring your attention to this diagram. Here, we can see several clients and one server. The clients will make the requests to the server, such as update my health or deal damage to the client C. And the server would be in charge of making sure that each order received from the client is properly processed and the correct result is delivered to the correct client. Notice that we have multiple clients, but not multiple servers. Each instance of our world is assigned a single server to communicate with, just the same as a waiter is assigned to a single table. There may be multiple tables in our world, or in our analogy, the restaurant, and each table is an instance of our world and is assigned to a single server. As of this recording, the current maximum player count per world instance is 100. And as soon as that world instance or table in our analogy is full, they must go to a different one that has an open spot. So here we have user A and we have user B. User A wants to communicate something to the server. So they will provide some form of input to the client device to trigger an action. The client will then notify the server of the action and make the request for data. The server will then process the request and deliver the necessary data back to the client. And if it's necessary that the other clients must be made aware of this order, then the server may also let the other clients know that user A has requested this information so that the other clients will have the latest on what's going on. Now that's a lot of concept that we've gone over, but what does this look like in practice in the context of components and properties that we've learned about so far? Well, to begin, a property is essentially a variable in MapleStory Worlds that manages communications between the client and server for that property. We'll learn how to declare a property in just a moment, but when we declare a property, Worlds gives us the option to either let MapleStory Worlds handle the synchronization or decide to leave the synchronization to us. Now, each client has its own copy of any given property, so when client A makes a change to their copy of the property, the other clients won't necessarily know that client A has changed their copy of the property. The server, just as the clients do, has its own copy. Let's say that we had a function defined on a component that we created, method B, and a property, property A. And the client and server both have their own copies of that component. And let's say that method B modifies the value of property A. When method B is called from the server, it will modify the server copy of that property A. And similarly, if method B is called from the client, it will update the client's copy of property A. Unless the value of property A is delivered from either the server or the client, neither will have access to the other's property. All this to say that proper management of the information held by each of the clients is necessary for proper synchronization between the client and the server. Now, as I mentioned earlier, a property can be marked as a synchronization property, so that MapleStory Worlds will automatically handle the synchronization of that property across the server and all the clients. So if property A is modified from the server, it will then update all of the copies of the property on the client side, even if we don't manually send that data to all the other clients. Of course, if the property is not marked to synchronize, it will not update the other clients unless we manually do so. When one client makes a change to a property, and if that property has been marked to be synchronized, it automatically communicates the change to the server, who then communicates and updates the property to all the other clients. So we are now in the maker, and as usual, we just have a simple layout here with some terrain and a spawn point. Here's our Lua script that we've been writing and learning from for the past couple videos, but this time let's actually learn how to create components. So we will right click, we will navigate to the scripts, and we will click on create component. And this time, let's name this my first component. We'll double click this to open up our component. And up here, we have the name of our component, open brackets and end curly brackets to define the start and end of our component. And then finally, we have some fields here. We have a property field, we have a method field, and we have some event handler fields. We'll go into the method and event handlers later on, but for now, let's first focus on the property field. Now, when we click on this plus button, it creates a property for us and we don't need to manually write out our code. In blue, we have the type of our variable. So before in Lua, we didn't need to necessarily define a type associated with our variable. When declaring properties, we have to declare the type of the variable beforehand. So when we click on this blue, we can choose between all of the different properties available. For now, we will keep this as a number. And then in the middle, we can choose to name our property. Currently, it automatically named our property new value 1, but let's say that this is a health component, so we'll say health. Then we have the assignment operator and then the value that we want to assign our health to. So when we define a property up in the property field, and if we assign the value to our property, this is called initialization. So this is the initial value that our property will hold. So let's say that we want 100 health for our property, and when this component is attached to, let's say, our player, then this value will automatically be populated with 100. However, as we apply this property value to multiple entities, each entity could have a different value for this health field. So let's look at an example. We'll go into our default player, we'll click on add component, and we will add our my first component. When we press enter, we can verify that our component has been added in. Up here, we can see our component, the name of our component. We can see that it has been enabled, and we can see the value of our property that we defined. So when we first attach the component, it has a value of 100. Now let's go into our scene here, and let's go into our preset list. And let's drag in any monster. Let's bring our coffee machine friend here again. And we will go into his properties and let's attach the same component, my first component. Notice both of these have the value 100 on both this component as well as a character here with the value of 100. But I can change the value to, let's say, 200 for my character. And the monster, let's say, could have 75. So even though the initial value when it's first attached to a component starts at 100, they can be modified to different values depending on how we assign them in the property inspector. And this is the way that we've been modifying properties so far. We have the same component being reused for multiple entities, but they can have varying values depending on its use case and what the entity is being used for. Moving on, notice that in brackets, we have the word sync in green. This is the automatic syncing of this property across the server and the client. When we mark this property as a sync property, MapleStory Worlds will automatically manage the synchronization and the communication between the client and the server of this property so that when we modify this property, it will automatically be updated for all of our other clients as well. When we click on the sync in brackets here, we can cycle between the different synchronization modes. We have our sync, as we've discussed. We also have what's called a target user sync, which we will not go into in this video, but it is essentially an optimization step where we can target certain synchronization to specific clients. But again, for now, we will kind of skip over this into the none tag. Now the none tag, as the name suggests, will not synchronize this property at all. So when this value is changed either from the server copy or from the client copy, this version will not be changed at all. And if we want any kind of synchronization, it will have to be manually synchronized on our side by communicating through messages back and forth between the server and the client. So to recap, we can define a new property by clicking on the plus button next to the property section. We can define whether or not we want to sync the property or not. We can click on the text in blue to change the type of property that this property will be. We can choose to be a string, an integer type, a number type, and hopefully a lot of these types are familiar to you, some that you haven't seen before. We also can name the property by giving it a new name, my new property, and we can assign it a value. So if I set it as a string, the value type would be a string type. And when we define a property, it will show up in our component inspector, my new property. And depending on where it's attached to, each entity will have its own versions of the property. So now that we've gone over properties, this time let's go over methods, which are MapleStory Worlds functions. Methods are defined in the same way that we define properties by clicking on the plus button on the right side. And we have a lot of different options to choose from. We have the new option, which will just create a blank function. And the function syntax for methods are slightly different, where we don't have the keyword function and we don't have the end keyword at the end of the function. The way that MapleStory Worlds functions are defined is, first, we have the return type. If there is no return type for this function, we can just set it as void, but we can choose from a lot of different return types for this function. We can choose the name of our function, so we can say sum, and we have the open and close curly brackets for our function definition. We can open up this hamburger menu on the right side, and the type of this parameter can be defined as anything we'd like. Since this is a sum function, we can choose a number. We can name our parameter a, and we can add maybe another parameter, make it another number type, and maybe name this one b. We can change our return type to maybe a number so that when we add these two numbers together, we will return some sort of number value. And inside of this function, we can define a variable like we've learned before in Lua. So while the properties inside of MapleStory Worlds for properties and methods have its own syntax, when we define code inside of our functions, we will use the same syntax of Lua that we have learned already. So we will use a local keyword to begin our variable. We can name our variable final sum. We can assign this to the value a plus b. Then we can return the final sum. So this function will return a number type. It has two parameters, a and b, and we've defined a local variable. And we assign that to the value a plus b, and we're returning the final sum. So MapleStory Worlds methods are very similar to the functions that we've already learned, just in a slightly different syntax. Moving on, we have several other types of functions that we can define under the event method category. Now, event methods are various methods that are called automatically by MapleStory Worlds at different checkpoints in the execution of our world. So to learn a little bit more about event methods, let's dive back into our presentation to learn about event methods. Script execution events are methods called by the MapleStory Worlds platform at different stages of the world's lifecycle. There's a lot of different events to discuss, and I've categorized these events into three main steps: the initialization step, the logic step, and the cleanup step. In the initialization step, these methods are called before all of the entities have been fully constructed. So during this step, all of the entities and components may not have been fully created yet. So we have two main initialization events, OnInitialize and OnMapEnter. OnInitialize is called once the entity and the components attached to is fully created, however, before all of the other entities and components in the map have been fully created. This includes the other components attached to the same entity as well. And this means that while you can refer to your own component's properties, you cannot refer to the other components even if it's attached to the same entity as your own component. OnMapEnter is called once the entity enters the map. Similar to OnInitialize, this component only guarantees access to the entity it's attached to and its own component, and not any other components. During the logic step, OnBeginPlay guarantees all of the components and the entities have been fully created. So this means that if I were to access the other component's properties, I can do so in OnBeginPlay. OnUpdate is called after all of the initialization steps and OnBeginPlay and is run once every frame. This method is commonly used for physics and other movement-based logic that needs to happen every single frame. The OnSyncProperty is called whenever a property marked as sync is changed on the server. So if you need to know the moment that a property changed, for example, if a health value changed and the client needs to receive the update, you might want to know the moment that it updated so that you can update the relevant health UI, for example. During the cleanup step, onMapLeave is called anytime the component's entity leaves a map. So this is good for any cleanup steps that are required before moving to the new map. OnEndPlay is called before the entity of the component is destroyed. This next graph shows a lifecycle of a release world. We won't dive into these graphs in this video, and I do encourage you to explore our documentation on the MapleStory Worlds lifecycle to study and make note of the subtle differences in execution lifecycle of the maker versus a release project, so you know which events to use and when. So we are back in our maker here, and we have our MyFirst component open. And remember that we attached our MyFirst component to our default player object, so we can see it attached here, but we also attached it to our monster here, right there. So just so that we're not having two different scripts executed at the same time, let's delete our monster so that it's only on the default player, and we can continue. So if we click on the plus button again, we can see all the different methods that are available to us, and hopefully now it's a little bit more familiar in their purpose and what they're intended for. And we won't go into all of these in this video, but we will go over the core events that we discussed that you'll be using most often during development. So let's click on OnInitialize first. And notice that we have a tag above our method, ServerOnly. Similar to properties, we can define where these methods exist. And we'll go into the execution in a little bit, but we'll just keep this as ServerOnly. But we can change this if we like into execution space setting. And we have the option between ClientOnly, ServerOnly, and NotUsed. We'll go over the differences in execution space control in just a little bit, but for now, we'll just select ServerOnly so that we can run our function on the server side. Okay, we've done a lot of logs so far, so let's do another log just to check. We'll do a log of initialized, and we'll concatenate that with the self.entity.name. So what am I doing here with the self.entity syntax? Well, the self refers to the current component. In this case, it is my first component. So any component by default has access to the entity that it's attached to. So when you create any component, automatically it will have access to the entity property, which just is the reference to the entity it's attached to. Then we can get the name of the entity. So the entity has a property called name that we can access, and we are printing that out to the console along with our initialized text here. And we will make sure that both the client and the server are both visible, because this time we want to make sure that we are executing on the proper space. Because our component OnInitialize is being currently selected to execute on the server, we should only see a server-side log. So let's press play. And we can see that our log is being executed on the server, and we're getting the initialized text along with the name of our entity, which is this kind of ID here. So this is my user ID. When a player is spawned into our world, by default, the name of the entity of a player will be the user ID. Okay, so let's stop play and head back into OnInitialize. And let's create another component. So we'll create another component and we'll name this my second component. And this time, let's create a new empty entity, and we'll name this some entity. And let's attach my second component to this entity. And let's try to access this entity. So to grab this entity, we can create a property, and we don't want to sync this, or we don't need to sync this rather. And we'll assign the type as the entity type, and we'll call this some entity. Now we have an empty field here where we can initialize this property. We will click on this little circle here, and we will select SomeEntity to assign this value to SomeEntity. So now we have access to SomeEntity in our component. So this time, let's try, instead of accessing the self.entity.name, we will access the self.SomeEntity, which is a property that references this entity that we've created here. And we'll use a dot operator, and then we will access the name of our second entity. So remember, OnInitialize doesn't guarantee that all of the other entities have been created. So maybe we'll get lucky, maybe we won't, but let's press play to see if we can access the other entity's name. Okay, so this time we were lucky, and we did get the name of our entity. This time, let's duplicate our SomeEntity here. We'll drag it above SomeEntity, and we'll rename this some other entity. And let's remove our second component and replace this with my first component. And we'll see that it's initialized to the same values with the same reference. And if we press play now, we have one log that's resulting in an error saying that SomeEntity is nil, and another one showing that SomeEntity exists. So we have my first component currently attached in two places. We have my default player, and we also have my some other entity. So both of these have my first component. However, depending on when they're created, they have a different execution order and different time that they're created in this world. So this is just an example to show that OnInitialize isn't reliable to reference anything outside of your own component to reference other components and entities. So it's useful for initializing properties and calling methods within your own component, but not within the components of others. Moving on, let's remove our OnInitialize method. And this time, let's try adding our OnBeginPlay method. So this is called after initialize, and this is called after all of the entities and components have been created. So we have guaranteed access to any entity that exists within our world at this point. So let's try this again. Do log, and let's try to access our SomeEntity value. So we will do self.SomeEntity.new. And let's try pressing play. And you can see that SomeEntity is being called twice, once from my player and once from some other entity. So both of these have access to SomeEntity, and they can call and grab the name of my entity. So if you do need access to other components and you need to initialize and your code depends on other components, this is where you would put your code. Okay, so before we move on to the next step, let's just quickly go over accessing the components of other entities. So at the moment, I have my second component attached to SomeEntity, and we already have access to SomeEntity within our property here. But let's say that we wanted to call a function in my second component. So let's open up our script for second component, and let's create just an empty method, and we'll name this hello world. And we'll do a log of hello world. So this is a function that exists on my second component. From my first component, I can use the dot accessor to directly access this entity's components. So I can do my second component, and then I can do dot, and I can access the properties, or in this case, the functions. So we created hello, oh, I spelled that wrong. Hello world. So we can access hello world and call that. We can also access the properties. So we can log out self.SomeEntity.my second component dot my new value 1, which is here. So let's press play and see if this works. Notice that we are getting this twice because this component exists in two different places, once from our character and once from the some other entity object. But we can call hello world from our second component from both some other entity and from our default player. We can also access the properties from both as well. Let's move on to our next event function. We'll remove this. And let's also get rid of some other entities so we don't have two entities at the same time, clogging up our console. Let's click on the plus button next to our method, and we will call our onUpdate. And this time, let's just do a simple log, and we will log self.entity.name. So we're getting the name of our entity, and let's press play to see what happens. So currently I have the collapse option enabled, which condenses logs that have the same content together. And we can see that every single frame we are calling update, and it's logging out our entity's name, which is our player name, out to the console. So this is going to get higher and higher and higher because it's being executed every single frame. We'll remove this. Let's move on to our final event method, OnEndPlay and OnDestroy. So let's log out in each of our event functions, OnEndPlay and log OnDestroy. So before these can be called, we have to destroy our object. So let's use the OnBeginPlay to destroy our object, and to destroy it, we can simply do self.entity, which again is referring to the entity that our component is attached to, and we can use the colon to access the different methods, and we can call the destroy function. Now, if you're ever curious about the different methods that you can call from the entity, you can go up into help and you can go into the API reference. And this will open up the API reference page, and you can search for the entity. And the first result here, you can see that we can go down and we do have a destroy function here. So this simply just destroys an entity. There's two versions of this function. We have the basic destroy that immediately destroys an entity, or we can pass in a parameter that destroys it after a short delay. So we know that OnBeginPlay is the start of the main logic of our code and is called after all of the entities and components in our map is created. So let's press play. And we can see that only OnDestroy is being called at the moment. The reason for that is that OnEndPlay is only called when the object is destroyed by the maker as a result of leaving the map or stopping play. So let's actually comment out our destroy function in OnBeginPlay and press play one more time. And this time, let's simply stop play. And we can see two logs being output to our console. We can see OnEndPlay and OnDestroy. So this is a very important distinction to make, where OnEndPlay is only called when the object is destroyed as a result of cleanup through changing maps or stopping play or leaving the world. So we have one last concept to go over before we close out this video, and that is the concept of execution space. So far we've been running all of our different event functions on the server side. However, if we go up into our hamburger menu and we choose the execution space setting, we can see that we can choose between client only or server only for our event functions. We also had this third option, not used. If we try to access the execution space setting of our other functions, so these are our custom functions that aren't the MapleStory Worlds event functions, if we go into the execution space setting, we can see that we have a lot more. And not just client only or server only, we also have access to the client, server, and this multi-cloud, and this other option called Multicast. So what does all of this mean? And what is the difference between server only, client, server, and why are there so many different ways to execute our code? Well, let's go back into our presentation and talk about it. When we define functions in MapleStory Worlds, we can define whether the function is a server-side function that exists and is called from the server, or if it's a client function that can be called from the client. Let's say that we have a component with two methods, method A and method B. Method A calls method B, but where the function exists will determine where the function will execute. If both method A and B are in the same execution space, it will be called from within the same execution space. However, when two different methods are in different execution spaces, that's when client-server communication happens, as we saw in our restaurant analogy. This time, let's assume that we had three methods. A exists on the server, B exists on the client, and C exists on the server. When method A calls method B, because B exists on the client, the server is sending a message down to the client so that the client can execute that method. Then, when the client-side method, method B, calls the server-side method, method C, the client is sending a message up to the server so that the server can execute method C. Each method in MapleStory Worlds can be defined as a server method or a client method. So we have several different types of execution spaces. We have NotUsed, we have client, ClientOnly, server, ServerOnly, and Multicast. With the NotUsed type, the method will inherit the execution space of its caller. So if method A is called from the server, method A will also be a server-side method. If method A is called from the client, method A will be a client-side function. So whoever calls method A will inherit the same execution space as its caller. Method B is marked as a client-side method. And what this means is that while the server can call method B, it won't actually be executed from the server. It will first send the message down to the client so that the client can execute method B. If the client executes method B, there's no need to send the message up to the server because it's already a client-side method, and it will just be called directly from the client. Method C is a client-only function, and what that means is the server is not allowed to call this method at all and can only be called from the client. Method D is a server-side function. So when the server calls method D, it exists in the same space, so there's no need to communicate back to the client. But when the client executes method D, the client will send the message up to the server so that the server can execute method D. Method E is a server-only function. And just like the client-only function, the server-only function can only be executed from the server side, so when the client tries to execute it, it will not be possible. Multicast will be executed once from the server and once from the client. So method F is a multicast function, and when method F is called from the server, it will be once called from the server and then called again from the client. Notice that a multicast function cannot be called from the client side. So we're back in our maker again, and let's clean up some of these methods that we have. And let's use OnBeginPlay this time to go over our example. And instead of calling the sum, let's remove this sum function, and let's just create a new function, and we won't define an execution space for this yet. And we will simply just name this hello world. And we will log out hello world. OnBeginPlay is a server-only function, so it will only be called from the server, but this is being called from MapleStory Worlds automatically. So from the server, when we call hello world, and we press play, we can see that hello world is executed from the server and not from the client. So we have access to both the client and the server right now, and it's only being executed from the server. And this is because hello world is not using an execution space at all, and it's using the NotUsed type. So because hello world is being executed from the server, it is also becoming a server-side function. If this was executed from the client side, so let's change OnBeginPlay to be a client function, and we press play again, hello world is now called from the client. Now, let's say that we call from the server, so let's set OnBeginPlay to the server function, and let's say hello world is a client-side function. So we can see this icon signifying that from the server side, we are sending a message down to the client and calling our hello world function from the client side. And we can see that it's executing from the client. Next, let's change it to be a client-side function. And we have our client executing the client. So this will, of course, just be a client function. And this is executing from the client. Next, let's try executing a client only from a server. So let's change OnBeginPlay to be server only. And we'll attempt to call hello world, which is a client function. Or sorry, we have to change this to client only. So if our hello world is a client only function, we can see that we have an error saying that we cannot call hello world because it is a client only function. And we can see this relationship here where we cannot call a client only function from the server. If we change OnBeginPlay to a client only, then because our hello world, a client only function, is being called from a client function, we can now call hello world. And we can see that it works here. Next, we have a server function. So let's try calling a server from the server. So we'll change OnBeginPlay to a server only function, and we'll change our hello world execution space to server. And notice the icon has changed because hello world is a server function, and this is just indicating that we are calling a server-side function. And you can see that hello world is executed from the server. And then next, let's try executing a client with a server function. And we can see that this is still possible, and it's sending up hello world and being executed from the server from the client. Now remember, when we have a client-side function executed from the server or a server-side function executed from the client, we can see these arrows in between where communication is actually happening. So this is where data is being transferred between the client and the server. So it's important to try to keep the messages that you're sending up and down from the server to a minimum in terms of the parameters that you're passing back and forth. Okay, so moving on, we have two more types. We have our server method, and let's try calling a server only function. So let's change this to server only and change this to server only. So we're calling hello world from the server, and hello world is a server only function. So this will work, and then it's being executed from the server. And then finally, if we change our caller to be a client, we can see the X again, saying that because hello world is server only, it will not execute from the client. And then the last type is our multicast. So let's change this to be a multicast and change our OnBeginPlay to be a server side. So we're calling hello world from the server, and notice the icon has changed to multicast now. So this is just indicating that this function is a multicast function. And remember, when we call a multicast function, it is called once from the server and then from the client. So we should see two logs here. And we can see that this is true. First, it's being called from the server, and then it's being called from the client. So we can see one from the server and one from the client. But of course, as we can see from this graph, we cannot call a multicast from the client. So let's change our BeginPlay execution to a client only. And we can see that it does not allow us to do so. So with that in mind, let's return to the concept of properties and remember that we had a sync tag associated with each property. So we can either choose to sync a property or we can choose not to sync a property. So currently, the myNewProperty has a string type of hello world, and we have chosen to sync this property, and the health, we've chosen not to sync this property. So let's change our hello world to maybe print property. And instead of logging hello world, let's log both of these properties out. So we'll do self.health and we'll log self.myNewProperty. And we will call the print property. And remember, we cannot call a multicast from a client function. So we will change this to server. And then let's try setting our health. So let's say self.health equals 10 and self.myNewProperty equals changed the text. And let's try pressing play. So we got from the server side, we have 10 and change the text. So on the server side, both of these values have changed. But on the client side, we can see that they remain the same value. Remember that even though our health is 100 right now, in our default player, we've changed this up to 200. So that's why we see 200 here, but 100 here. And that's because in the inspector, we've modified this value. So we have my new property as synced. So why doesn't on the client we see the change? Well, this is because the change hasn't happened yet. So after we change the property, the server sends a message down to the client to update that property. So we can utilize the OnSyncProperty, and we can do if the name equals my new property, then we can log out the value. Else if name equals health, then log out the value. Actually, we can just change this to or, and we don't need the else if. And we can just do or name equals health, then we'll log out the value. So OnSyncProperty will give us the name of the property and the value that was changed. So we'll log out the values for the changed values. And we can see that we have just one message changed the text. And the reason why we don't see the value 10, even though it was changed from the server, is because we've marked our health value as none, so it does not actually sync. So if we change this to sync instead, we can see that now we have 10 being logged and change the text both on the client and the server. So OnSyncProperty will give you the exact moment that a property is changed from the server side to the client side. So hopefully this helped you understand the relationship between client and the server and how different functions are called from either the client side or the server side. Thank you so much for joining me in today's video. Today we learned about some MapleStory Worlds specific scripting concepts, and next time we'll learn about some custom events and try putting these concepts together to finally create a simple game.